Quite interesting here, the grid wire was attached to this nasty wire lead that appears to go back to the antenna coil, I'm guessing. Anyway, I'm going to go ahead and snip this off. And I'll leave this here as a reminder. Hook up here and give the primary of the power transformer a quick check. Flip the receiver on, and we've got DC resistance. Not consistent DC resistance, but again, probably just a dirty switch, looking at how gross the switch looks. Pull the rectifier tube out and double check the 5-volt winding and the high voltage winding with my tube socket adapters. Just make certain that we've got continuity there. Pins 4 to 6 should be the plates. Okay, roughly 0.770 or 0.769 K, so 700 ohms between those 2 points. Let's check the filaments 2 to 8. Looks like we're in good shape there. You can see less than 1 ohm, 0.6. You guys excuse the background noise. Real humid day with some rain, so the dehumidifier is cycling. Let me pull one of the other tubes out. Let's check the 6.3 volt winding. Make sure we're 1 ohm or so, plus or minus a bit. And pins 2 to 7 should be our heater string. So I think we're going to be okay there. I'm going to pull this power transformer off of the receiver chassis anyway to do some de-rusting, clean up any lead dress issues. Let me go ahead and get the remaining tubes out. By the way, I'll double check later just to make sure all the tubes that are here are a match for the schematic. Cleaned off the tube that I removed here, the 6F6 GT, the output tube. Let me get these others removed. The 6Q7 GT. For folks that are new in the hobby, you'll see I'm not reaching in here and trying to twist off the grid wire. Many times you'll find the grid caps loose from the tubes, which in many cases can just be easily repaired. The old rust on the grid cap connections makes it a little tight. And you can see this one's already loose. And again, pulling up from the base of the tube when all possible. Okay, the 6K7 G tube. See if I can pry this one up. That's what I found there with the grid wire running back down to this lead. So it does make me wonder if we've got an antenna coil issue or something. Tell you what, let me just place that back on there for a second. Alright, the 6 alpha 8. So this is our first detector oscillator tube. Kind of makes sense. Someone may be trying to improve reception and running a lead directly from the antenna back over to the grid cap of the 6 alpha 8. So more due diligence there will be required for sure. Already looking much better, but a good ways to go for sure. There's the dial string, what's left of it. Looks like this thing was maybe around a maple tree. Definitely see where the mice like to party in the past. Pretty gross right back in this area. You can see the tuning condenser wiggling back and forth as well. Looks like the rubber grommets that were used have degraded, which is common. I'll be removing it completely from the chassis anyway. We'll give it a bath, de-rust it, and then clean it up. This thing is gross up here. Looks like the mice played a lot in this area. I think in the earlier video I was kind of pointing down in this area as well. This appears to be a tone control, if I've recall correctly from my first glance at the schematic itself. You've got a capacitor there that's shunted to ground. You guys may be able to pick up on that, the serial number 288403. Made in the United States of America, 117 volts, and you can see around 50 watts or so. I'm going to take some still photos of this marking here on the back. When I do the rust removal, more than likely it's going to come off, so I may try to just reproduce that just using a laser printer transfer method. Cool dial, even though we're looking at it upside down. Alright, let me pop this thing back around. Let's take a look underneath the chassis one more time. I still need to take this thing back outside and see if I can vacuum or use some forced air. Blow a little bit more of this crud out without breathing it. You can see the band presets with all the trimmer locations here. Definitely a lot of rust in this area. These are corroded up. Hopefully they'll clean up. These things can be a pain in the butt at times. You can see though, I think this thing probably was worked on at some point. You can see a mica mold capacitor back here in the back, that greenish color. It doesn't appear to be original, but I'm guessing these other caps are the original, and who knows, this may be the original E-cap as well. Hard to say for sure. Might be able to match some part numbers up later on. Hopefully I can get the power transformer out without creating a significant issue here with the lead wire dress. That's a common problem. These things just get really degraded and they'll just crumble up on you. Looks like the output transformer at this location. We'll see if that's original or not. Check out the first video. Look at the comments. Steve's already done some research using the Sam's Red Book. And I haven't had a chance to study his notes yet. You can see some stuff right here already bypassed. We've got a lead coming over, so maybe that was, an E-cap replacement at some point in time. Go ahead and take this thing back outside, see if I can get some more of this crud out from underneath. It's just floating around in there. And then do another wipe down on top of the chassis. Then I'll decide what's next. I may go ahead and pull the tuning condenser off first, or I may go ahead and just tackle the power transformer and remove it, so I can do a closer inspection on it, fix any lead wire issues, and get that rust off of the bell housing, and see if I can clean up those laminations as well. Okay, I think I made up my mind. I'm going to go ahead and do the tuning assembly first, get it off. It's so fragile. I noticed when I had turned the receiver upside down just a minute ago, I had already deformed the pointer just a bit. So I want to go ahead and get it off and then get the dial scale off. And I'll go ahead and scan the dial scale as well, so I'll have a copy of it just in case something happens along the way here. This thing is kind of seized up on there. I'm going to take a little bit of WD-40 on a Q-tip and see if I can get it on the stem or shaft and loosen this thing up and pull it off. Okay, there it came off. Okay, that was easy enough. I'll pop the dial scale off most likely as well. so I can just finish cleaning up the rust around this area. I may be able to actually leave it in place. You can see 2 springs if that's done correctly for the dial cord. We'll see if we can find the diagram for that, or just reverse engineer it, no big deal. Cool thing is the tuning condenser is not completely seized up. It's stiff, but rotates more freely than I had imagined. Still finding crap in this thing. This thing's a little heavy with the iron from the power transformer still attached to the chassis. Try to hold that up where you guys can see the pre-selector adjustments there for the tuning condenser. All of the trimmers, that whole bank there, they're soldered to the chassis. You might be able to see that. And you can see the short leads back to the switching mechanism. I need to take the switch off to be able to get to the tuning condenser fasteners, which reside underneath that. So let me take some still photos, so I'll have that for reference in addition to the schematic itself. And I'm going to just cut the leads loose in close proximity to the little trimmers. And it looks like 2 fasteners that hold the switch assembly in place. Get that removed. Zoom in here just a bit. You guys may be able to see this. Looks like the rear section of the tuning condenser. You can see it coming up from here. Tan wire connects here. And I've got another section closer to the front of the chassis that comes up right here. Wiggle that just a bit and attaches at this location. And then this other wire right here, looks like it's a greenish blue tint, attaches right back in here. That may be the only 3 connections. Well, then you got this bare wire as well at this location. So maybe those 4. And then the remaining green wire. And if I looked at this thing correctly, I think it's just these 2 fasteners right here. I'll need to remove the push buttons as well. Just make sure this falls backwards. Alright, let me see if I can get those push buttons off now. Just a little shot of WD-40 on each one. Okay, one down. It's like one was stiff and the other's very simple there with just a little WD-40. And let's see if I got all the connections loose here. And it looks like that was it, just those 4 connection points. You can see this thing is seized up. See if I can get that working. These things are not very tight, so looks like I can just use some needle nose pliers and get back in here and actually remove these. And just take note of the washer locations as well in relationship to the grommets. And then we'll have the tuning condenser removed. Okay, what we had again was the nut followed by a lock washer followed by just a flat washer, then the grommet. Then on the top side, just the grounding strap back to the tuning condenser. Leave a little stub. Now we have one dirty tuning condenser. All right, I'll examine these grommets later in more detail. For those that are new in the hobby, it's always a good practice in most cases, even with your documentation, to go ahead and place the fasteners in the correct orientation. Back on. I'll repeat that for the other two that are late. You guys can reference the side-by-side or the picture-in-picture. I've got the schematic pulled up of the front end of the receiver. This particular chassis does not have that wave trap circuit, so you can ignore the area I have highlighted here in red. And we'll just focus on the primary and secondary. The primary will be easy to determine. You can see we've got resistor number 48 going to ground. And that's this resistor right here. And if you look closely, you probably can't see this on the camera angle that I'm sharing, but this end of the coil goes back down to ground here. So that represents that connection point for the primary. And the other side, of course, would be the top side of the antenna coil here that attaches back to this lead that goes to the outside antenna. So let me attach the one side of the meter at this location. Zoom out here just a little bit. And just make 100% certain here that my eyes were not playing tricks on me. So that definitely is our input antenna lead. So again, if you reference the schematic, I should be able to just go to chassis ground. And I'll just use the lead down here that goes to chassis ground. And we should be reading the parallel resistance of resistor number 48 and the coil itself. So let me cut this resistor right here that's going to ground. I mean, you can see very little difference. So the DC resistance appears to be somewhere around 28 ohms. Let's check across this resistor now. see what we read. I'm reading about 14K. Let me look back at the schematic again. So as you can see, again in the side-by-side or picture-in-picture, about 10K for this resistor, and we're reading about 14K. Thus the parallel resistance is not really influenced so much. So the only other two connection points I have on the coil itself will be this point to this point, and that should be again our secondary winding, which will be our tune circuit tying back to the tuning condenser. So let's check there and see what we have between those 2 points. So you can see we've got about 5.5 ohms. Again, the DC resistance is not called out on the schematic, so maybe we're in luck. Just to make certain that we're not reading DC resistance through this old paper cap, I'm going to snip it at this location. And no change. I just wanted to make certain it was not shorted. So once I get the coil removed, we'll do some additional testing just to ensure it's operating the way that it should. Let me grab my LCR meter and check the inductance of the coil. Hopefully that's showing up where you guys can see that. About 241 microhenries. So I think we're going to be in good shape there. That should resonate with the tuning condenser. Let me get the tuning condenser back up here and take a look at it. It looks like both sections of the tuning condenser, the oscillator section and the broadcast section, are the same. Let's just see what we have capacitance wise in picofarads. Do some simple math and just ensure that the inductor resonates across the broadcast band. Try to hold this where you guys can see it. I'm on the front section right now, and you can see we're around 16 picofarads up to a max of around 411 picofarads. Again, there'll be straight capacitance in the circuit as well that the designers would have taken into consideration. And this section, the rear section, reading 297 to 55. So we do have a difference. Let me look at this one more time and see what the difference is in plates. I'll actually see now. I thought the each section was the same, but you can see the rear section. It's going to be our oscillator section, I'm sure. I'll look at the schematic just to confirm. You can see the plates are smaller, thus the lesser capacitance from that section. Let's do some quick math and just see if we can understand again how the tank circuit resonates. Let me get these numbers again for reference. So around 55, 56. Again, there'll be plenty of stray capacitance, who knows how much, 10 to 20 picofarads, maybe even more. And 298. Let me go to the other section one more time. And try to get this where you guys can see it. We'll call it 412, 413. Down to about 17 picofarads.